Okay, let's get started with section 8.4, logarithmic functions. You probably have not covered logarithmic functions before in a math class. So the first thing we're going to do in this section, all we're going to do is learn to work with logarithmic functions and rewriting these in different notations, okay? So what a logarithm does is it tells you an exponent for a particular base to give you a particular number. So let me look at an example down here. Go to the bottom of this table before we look at the rules. If you're looking for the logarithm base 3 of 9, what you're asking yourself is, for the base 3, and we call that, see the subscript is the base, for the base 3, what exponent do you raise 3 to in order to equal 9? So 3 to the what power gives you 9? And the answer to that is the logarithm of base 3. Well, you just say the log base 3 of 9. And the answer is 2 because 3 to the second is 9. So this is logarithmic form, and this is equivalent. It's written in exponential form. So what we're going to do in this particular section is just change things in exponential form to logarithmic form and things in logarithmic form to exponential form. Keep in mind on this video that you can adjust the speed by going to the settings and play this at a slower speed if you prefer, or you can always stop, pause, and rewind to repeat something if you feel like you need to hear it again. Okay, so let's look at the rest of these notation-wise. The log base 4 of x means what power do you raise 4 to get x? Well, that's an unknown, so we write this as 4 to the y is x. And likewise, you can take something in exponential form. A to the power b is c. A is the base, so when I write it as a logarithm, I put the a as the base. And b is the exponent. Remember, that's the answer to the logarithm, so the b goes over here. And c is the value that we're taking the logarithm of. Okay, let's look at another one going this direction. That one is poorly typed. It should be 5 to the 1/2 power equals p. So my base is 5, and 1/2, the power is the answer to the logarithm, so the 1/2 goes over here, and we get a p. Okay, I like to think of this as sort of a motor thing. When I'm rewriting something in the log form, I start here with the base, and I kind of go around in a circle this direction, and that's the base, the power, and what it equals to. So we'll do some of those on the next page. So let's talk a little about the definition of a logarithm. For a base greater than 0 and the base not equal to 1, x will be equal to b to the y. It's equivalent to saying y, the exponent, is equal to the log base b, because that's the base in the exponential form, it's the base over here, of x. Okay, so you can see how we're doing that. And the same thing here, y is equal to log base b of x is read, y is the logarithm base b of x. Okay, so some more examples you can look through. I think it's important to notice this particular one. Whatever the base is, if you raise any number to the 0 power, it's 1. Okay, so the log of 1 is always 0. It doesn't matter what the base is. Okay. Let's go to the next page and start practicing some of these. See how this works. Okay. So we just said this, regardless of the base, the logarithm of 1 is always 0. And if you have the log base b and you get b, then it will always be 1 because b to the first power equals b. So that will always, if the base is the same as the value you're taking the logarithm of, you'll always get a 1. Okay, I think when I put my hand up there, it makes it glary. If you have a b to the log base b of x, that will be x. These actually we're going to get into in the next section and talk about these being inverse functions. So we'll come back to that in a little bit. So let's take these and we're going to express each equation in logarithmic form. This is my base. I'm supposed to write it as a logarithm. So we're going to have a log base b, and the base is 3, of, this is what I'm taking the logarithm of, 27. And in other words, 3 to what power gives me 27? And so this is the 3 right there. It's not great that the first example has a 3 in both positions, but the base 3 is the one that goes there, and that's the one that was the exponent. It's the answer to your logarithm. Okay. Let's try the next one. Rewrite this from exponential form into logarithm form, log form. The base is 2, and we're taking the log of 1 over 32, 1/32, and it equals to the exponent is the answer, -5. So in other words, 2 to the -5 is this, and that is true. Okay. All right. The base is 10 now. We don't have to write the base 10. That's sort of redundant. It's like putting one under numbers. We can just write it as the log, because if it's not written, it's assumed to be the common log, which means it has a base of 10. So the log, this is my base, and I'm taking the logarithm of 23, and that will give me x. So 23 equals x. This is probably the preferred way to write it, because again, sort of redundant. It's 10 if you don't put otherwise. This, you have to designate if it's not 10 what it is. And that's why we put the 2 there and the 3 there. Okay, let's move to the next page. Express each equation in exponential form. Now they're giving us these as logarithms, and we're going to write them in exponential form. I like these. They're easy, I think. I like going this direction more. I go like this, kind of make my little circle, right? So 5 is my base. The exponent is this answer over here, equals, and then 125. And then we can actually check, does that make sense? 5 cubed, 5 times 5 is 25, times 5 again would be 125. So we can see that that works. So the logarithm of base x of 4 would be 2/3. So the base is x. This is my exponent, so we're going around like this, right? The exponent is 2/3, and that equals whatever you're taking the logarithm of 4. All right, next one, the base is b. Raise it to the power 10, and that would be equal to 39. Okay, and we don't know what b is. Later we're going to learn to solve these, but like I said, this section is just about learning to rewrite and work with the notation. Change each equation into exponential form and then solve it. Okay, so this is a little trickier. We take the base, which is 3, and we raise it to the power 4, and that will give us x. And they want us to solve it, tell what x would have to be. Well, 3 times 3 is 9, times 3 is 27, times 3 is 81, right? So x is 81. All right. And the next one, write it in exponential form first. So the base is 5, raised to some power x, and that will equal, so I'm going around like this, 125. So 5 to what power is 125? Okay, and you could probably think about this. 5 times 5 would be 25, times another 5 would be 125. So the x has to be 3 here. Another way to work this, and I think this is a good way to think about it, let's write this number as 5 to some power. 5 to what power? Well, the third. So these exponents have, if the bases are the same, the exponents have to be equal. So that would mean x has to equal 3. And this is going to be helpful when we work a little harder problem in just a minute. This method of making the bases the same. Okay. Let's look at number 9. We're flying through these. The base here is x. We raise it to the power 5, and that will equal to 32. So this is a little trickier. What number to the 5th power? We haven't actually learned this, but I don't think you'll find it tricky at all. When we had like x squared and we wanted to know what x was, we square rooted it. So in this case, what we have to do is we actually 5th root it. We take the 5th root of x to the 5th. You can think about this and just figure out it's 2 by 2 times 2 is 4 times 2 is 8 times 2 is so forth. Okay, or we 5th root 32. And we can do this on our calculator, which I didn't bring it now, but you type in the one, not the square root, but the other root button on your calculator. And the fifth root of 32 is 2. So you'll get x, the fifth root of x to the fifth, that's like the 5 over 5 power, which reduces to 1. And over here we get 2. And like I said, you could say 2 to the fifth would be 32. You could start with 1. What's 1 to the fifth? Well, that's 1. What's 2 to the fifth? 2, do it on your calculator, 32. Okay, and then you know that that's the answer. Okay, so x needs to equal 2. That's the trickiest one we've done so far. Here the base is 25. We raise it to the power x, and that yields 125. Now this is one of those where, since the bases are different, let's make the bases be the same so that we can compare them better. So I'm going to think of 25. Obviously 5 divides both of those. 25 is 5 squared. Okay, and that has to go to the x power because 25 is 5 squared. I rewrote that. And I want to write this as 5 to a power. Well, that's 5 cubed, right? Remember, when we have a power to a power, we multiply those. So I have to move over here. I've run out of room. 2x. 5 to the 2x equals 5 to the third. Well, if these have the same bases and they're equivalent, then they must have equivalent powers. So 2x must equal 3. In other words, x has to be, divide both sides by 2, 3 halves. So x to the 3 halves. And you can check this if you want. You can take on your calculator 25 to the power, put a parentheses, 3 divided by 2, close your parentheses, equals, and you will get 125. All right, again, pause and stop this video as you need. Let's go ahead to these next few. We're to use the properties of logs to evaluate. So we're actually going to calculate logs, but we're going to think about them as exponentials because that's what we're most familiar with, okay? So I kind of like thinking a visual, the fill in the blank here, right? So really this log is an exponential in disguise. It's 5 to some power, and that's what I'm trying to figure out. What does this need to be? The answer to the logarithm is the power we need, and that will equal to 1. So 5 to what power equals 1? Yes, anything to the 0 power is 1, so it needs to be 0. So in this particular problem, our answer is 0 because 5 to the 0 power equals 1. Okay. So what I did was I wrote it as an exponential in order to solve it. So I'm going to do the same thing here. 10, that was one of the shortcuts. You may remember the answer to this already, but if you don't, 10, this is my answer I'm looking for. 10 to some power will equal 10. So I did it like this, right? 10 to some power will equal 10. Well, obviously it needs to be 10 to the first because that's a 10 to the first. So the answer, the logarithm base 10 of 10 is 1. And we learned on the previous page that the logarithm of any base for that same value will always be 1. Okay, that was on, I think, the second page. All right, so here, 4 to what power is 64? Well, 4 to some power is 64. I wrote the logarithm in exponential form, and now we're going to think about this. 4 times 4 is 16, times 4 is 64. So I have to cube the 4, check it on your calculator, cube the 4 to get 64, and we see that the logarithm of 64 base 4 is 3. And the final one here, the base is 10. 10 to some power, okay, we'll write it like this. We're looking for that blank. 10 to some power equals to 0.01. Well, this is 1/100th, isn't it? 10 to some power is 1/100th, right? That's not 1/10 would be there. That's 100th. So this, to get the 10 to the denominator, must have a negative exponent. Does that make sense? So if I wanted to write this as 10 to some power over here, it would have to be to the negative to make the 10 go to the denominator, 2 to square the 10. So we can see that the exponent needs to be negative 2. The negative, so we'll take 10 to the negative 2. Let's check this. The negative exponent we would rewrite as 1 over 10 to the positive 2, and then we would go ahead and square the 10, and we get 100th, which is 0.01. So this is our checking of that. Okay. That concludes this section. When you're ready, you can proceed to the next one.